Welcome to Modern Manufacturing 2020. We are super excited that you guys are here and that you're joining us today. My name is Maddie and I am a recruitment specialist here at ECTC. So if you're joining us live, go ahead and make sure that you're logged into your Google account or a Gmail account so that you can comment below. We'd love to know where you're watching from, or if you have any questions, comments, or concerns, you can go ahead and drop those in the comments as well. I've got Emmy off camera who's helping me with the technical side and monitoring those comments. If you watched any of our Facebook Lives this summer, you know how good Emmy is, so just go ahead and put that stuff in the comments, and we will go ahead and get started. It looks like some of you are watching, which is really exciting. And today we're going to focus on a few cool things that you would come across in the manufacturing process, which usually starts with a problem or a need that hasn't been met yet. And then those in the manufacturing industry work to create a product to meet that need or solve that problem. During our time together, we're going to see several demonstrations by ECTC instructors who are using innovative technology right here on campus in our lab spaces and classrooms that you might actually find in the industry. Among the things you might consider today while we're talking, and even when you're thinking about choosing a career path or maybe changing your career path, are job security, availability, and salary. And you'll actually see our instructors talk about some of those things today. So first, let's talk a little bit about advanced manufacturing and put it into context for those of us who may not be super familiar with the field and everything that entails. Advanced manufacturing is the use of innovative technologies to produce products or solve problems. It's a really growing field in all sorts of areas like automotive, aerospace, food and beverage, medical, and so much more. Here are some of the employers right here in our region, and you might recognize some of these like Altech that produces bucket trucks, Inoac, TG Kentucky, and Toyotomi that are automotive suppliers, and Midpark that produces structures for things like highway signs and overpasses. And again, these are just a sampling of the many right here in our regions and in your hometowns and maybe even your backyards. If you're technically inclined, you have an interest in STEM subjects, or you really like working with your hands, you may consider a career in advanced manufacturing. And you might be interested to know that Kentucky is third in the U.S. for automobile production, as automotive is our state's top manufacturing sector. Just last year, Kentucky exports totaled $31.36 billion in our Commonwealth, and our Commonwealth is home to over 4,500 manufacturing jobs. That is a lot. Manufacturing facilities, actually, sorry. So now the average annual compensation, we're talking about salary and pay here in manufacturing in 2018, was $72,614, and Kentucky manufacturers employ more than 18% of our workforce. If these numbers aren't enough to kind of entice you into the field, CreatorsWanted.org estimates that over the next decade, 4.6 million manufacturing jobs are going to need to be filled in the U.S. All right, you're probably tired of listening to me talk at this point. So we're going to go ahead and jump over to Brent in our CAD Lab, who's been working on a project. We'll actually check in with him a couple different times. So while you're watching, try to guess what he's actually making, and you'll see that finished product a little bit later. And just as a disclaimer, as we go through some of these videos and demonstrations, some of the clips from these were actually pre-recorded, or recorded pre-COVID rather. And here at ECTC, we are currently following all of our Healthy at ECTC guidelines. So let's go to Brent in the CAD Lab.
Hello, my name is Brent Doty, and I'm the program coordinator for computer-aided drafting and design. Basically what we do here is we solve problems. And actually I have something up there on the computer that I've been working on to solve a problem for myself. But what my students do is, we work on projects and different assignments, and the whole idea is to give them some kind of a whether it's create a model or create drawings that other programs could use, like CMM. They can make the parts that we actually create. So we work with all the other trades and other areas to solve a problem, and they're the ones that actually end up doing the fixing sometimes and completing the job. We're getting ready to print the part that I've got up here on the screen, and when you come back, we'll see how it's doing.
All right, welcome back. So that was Brent in the CAD Lab. I'm wondering if you already have an idea of what he might be making. We're going to check back in with him a little bit later to see some of the progress on his project. And if you think you know what it is, go ahead and drop that in the comments. If you're just now joining us, if you want to drop some things in the comments, maybe where you're watching from, any questions you have, or maybe your guess about Brent's project, you need to make sure that you're logged into a Gmail account or a Google account just to make sure that you can access the comments, but we'd love to hear from you. We are monitoring those, so just make sure that you're doing that. And if you are just now joining us, welcome. We're excited that you're here. All right, so we are actually going to go into our first full demonstration, which is super cool. I got to sit down with our computerized manufacturing and machining program coordinator, Grant Logston, and actually one of his students to talk about advanced manufacturing and see some of the things that his students are getting trained in and how they're preparing for careers in advanced manufacturing. So let's go check it out. Hey, so Grant has an EDM demonstration set up for us in the machine shop. Let's go check it out, but safety first.
My name is Grant Logston. I'm Program Coordinator of the Computerized Manufacturing and Machining Program at ECTC. I think it's a great field to pursue because if you're a student that likes to work with your hands, you like making things, you like taking things apart, putting things together, it's just a great field because we run all kind of different machines, and it's just a great field. We're going to use a wire EDM. It's an electrical discharge machine, a very high-tech machine. And we're going to cut out a 36-tooth spur gear that's actually going to be used on one of our other machines. The work here begins on the computer with Mastercam software. Our students will draw the part, assign a toolpath, generate the code, and then load it on a flash drive that will be uploaded to the machine. After the program is loaded, the EDM, which is an electrical discharge machine, uses 10 thousandths brass wire to cut out a precision part that will actually be used on another machine here in the shop. You can use any material as long as it's electrically conductive, but here we're cutting a gear out of aluminum. The brass wire comes into close contact with the work but never touches it. As the machining begins, 30 to 40,000 sparks per second will jump from the wire to the workpiece, exploding a path for the wire to follow. The wire follows the path with extreme accuracy to cut out the profile of the part. These machines are incredibly accurate and it takes extreme precision. The EDM can cut materials within 0.2 of a thousandths accuracy. That's like taking a sheet of paper and slicing it thinner 20 times. An EDM and machines like it are used to make parts for aircraft, tool and die parts in automotive manufacturing, for surgical equipment in the medical field, and just about anywhere there's a need for extremely accurate parts.
Hi, my name's Holden. I graduated from LaRue County High School. I'm a student at Elizabethtown Community and Technical College. I'm now working at Atlas as an apprentice, and I'm hoping within a year I can get up to $80,000 a year, and ECTC has helped me get there. What I love most about my job is that I get to be hands-on. We have big equipment that we work on for Toyota, the government, a lot of different companies that need giant stuff made, such as a gear that's 16 feet diameter. And it's nice seeing that we can make a difference in the industry.
I think the cool thing is some of the machines that we have are just absolutely fascinating. We'll use a computer to program something. We'll load it onto a flash drive, put it in a machine, set the machine up, hit start, and we come out with a finished product. And it is an amazing process.
All right, welcome back. That is super cool to me, and it really blows my mind just how precise everything has to be with those machines. That's one of the things that I was really interested in learning about in advanced manufacturing, is that it's not large, clunky machines in a dark, dirty basement anymore, which it's commonly misunderstood to be. It really is intricate machines with intricate measurements, and it really requires great expertise. So that's something that I was really interested in learning about advanced manufacturing. We're actually going to go back and check in with Brent in the CAD Lab and see the progress on his project.
Welcome back to CAD. Right now we're working on the printing process. I showed you how the creation process went, and now we're working on the actual making of the part. And we're using some filament here. This is a black color, it's a PLA. There's some other materials that we can use, and this is actually what we call additive manufacturing. It's similar to CMM, except it's the opposite, where they do subtractive and they start out with a block of material, and we just start out with this material here and it actually creates it. So this part takes about an hour to print. Some take longer, some are shorter, just depends, but we'll check back here in a little bit and see how it looks.
All right, this is super cool. I'm really excited to see kind of the process of things and how they're going with Brent. We've seen the beginning, starting with the computer drafting and designing part of that process, and now we're actually seeing him in the making part of the process, and so that's really cool to kind of see that over time. But I'm wondering if you caught the little tidbit about additive manufacturing versus subtractive manufacturing. You can tell that those in the advanced manufacturing world really are solving problems from all different angles with all different methods. And so I love that all of their brains are working together to solve it differently, but to solve the problem nonetheless. And we are actually going to go take a look at our next stop. Hey, so I'm in the electrical technology lab with Tim, and he's got a really cool demonstration set up for us. So let's go check it out.
My name's Timothy Cordova. I'm a professor here in electrical technology. I've been doing this for 18 years. So manufacturing, there was a time where we were shipping a lot of things overseas. I think America's realized that the best stuff's made right here in the United States. So I see manufacturing as sticking around for a long time. I also see the rise of robots. Robots are going to be used. They're going to be used in our homes. They're going to be used in industry to clean things when we're gone, so there's going to be a need for people who know how to repair those items. So today we're going to be demonstrating an industrial motor controls 2 pick and place that utilizes pneumatics. It's got a photo eye sensor on it. It's computer controlled by a programmable logic controller, and you'll see it use the pneumatics to pick and place a puck off of a conveyor system. So on this machine, this student used a personal computer to create a program that's downloaded into an industrial computer called the PLC. PLC is the brain for this process, as it controls all of the functions on the components. It works hand in hand with the variable frequency drive to control the speed of the conveyor and the dispensing of the pucks, and basically how quickly everything functions. This is important because when this skill is used practically in an industrial line on a much larger scale, everything has to be timed precisely down to milliseconds and even faster. This system uses a photo eye which senses the color of the puck compared to the conveyor belt. The conveyor belt is black, the puck is white. When it sees that contrast, it triggers a sequence of events, including the pneumatics to direct the airflow to engage the slide to pick the puck up using vacuum pressure. To put this in perspective, you replace the puck with a bottle cap, and your robotic system is now assembling bottles of bourbon, Coke, you name it, even ski. So robotic technicians make generally about $65,000 a year, and that's without overtime. So when you think about overtime, think about an extra $30,000 to $40,000 a year depending on that overtime. We also have process control technicians. When you think process control, I like to think about distilleries. I think it's most cool really because when you think about the future, I keep thinking about how it's changed. So from when I started to where it is now, when I started, no robots, now robots everywhere. That's pretty exciting. And when you think about the pay that's going to keep going up and up and up with somebody who needs to know the skills necessary to work on those things, I think that's what's the most exciting.
All right, thanks, Tim. That was a really super cool day for me to get to go and sit down with Tim and talk about his program and also talk about the future of advanced manufacturing. You can see that this field is not only changing and growing rapidly, but it is one with job security and staying power, which is really important in a world that is changing so much. So that really is something that you might think about. And another thing that you might have noticed in these demonstrations is that just the diversity of the students in our programs and the students in this field. For example, more and more women are finding great careers in advanced manufacturing, and our instructors and employers would tell you that there's nothing that a woman can't do in this field. I've looked at the comments and it looks like Emmy thinks that this is super cool, so do I. Again, if you have any questions or anything and you're logged into a Google account, make sure you just put those in the comments. But we are actually going to go ahead and move forward and check back in with Brent to see the finished product. So let's go see what he made.
Welcome back to CAD, and this is our last installment. And you're probably wondering what I was making. Well, I'll show you. It was actually a buckle for my backpack to help keep this strap from moving. I don't know if it's going to completely fix the problem, but at least I'm on the right track. Basically, the way the CAD program works is you start out by doing some hand sketches, some hand drawings on a board similar to what I'm sitting at right here. And then they move on to the computer and they start doing the same thing but on the computer. And they move from 2D drawings into 3D drawings and making the models. And then you can either go to 3D printing, you can create the drawings that the other areas use, like CMM or electrical. We work with them to create drawings that they read. We'll create the actual drawings for the solving of the problem, whether we're doing the solving or somebody else is. Most of the jobs are set up as a designer type job. They might be called CAD operator, CAD designer, or just designer. And you can be mechanical or architectural. Usually they make somewhere between $15 to $20 starting off. And, you know, it could be more. It really depends on your skill set. Well, the real reason that I like it is because it's cool to solve problems. I have a lot of students that they enjoy making things. Not just 3D printing things, but actually designing something that they can say, hey, I did that. You know, like if you designed a house and you can see it built and then you're like, hey, I drew that. That's what CAD's all about, solving problems.
Okay, if you guessed that it was a buckle, then you were right. I love how he mentioned that he wasn't sure if his design or if his buckle was actually going to fix his problem, but that at least he's off to a good start. A lot of problem solving, as you all know, is trial and error. But he's working to achieve a goal, which is super cool. And with the technology that we have available, I'm pretty sure that there is no problem that you can't solve. And Brent actually put his problem solving skills to work earlier in this year when all of the COVID mess started, and we had some healthcare professionals in our community that needed face shields, and there was a shortage. And so Brent and his team actually designed the plastic piece that attaches to your forehead that actually affixes the shield to your face. And so he made hundreds of those and sent those out to our healthcare professionals. So way to go, Brent. We're really happy to have you here at the college. All right, so we do have one more stop, and I'm wondering if you're ready. Whew. So we're here outside the robotics lab with the engineering and electronics technology program. Marty has a pretty cool demonstration set up for us, so let's go check it out.
I am Marty Sutherland, and I'm a professor here in the Engineering Electronics Technology group. Today we're going to watch a FANUC robot simulate a weld demonstration. What you see here is a FANUC welding robot. We're lucky enough to have 5 small pick-and-place robots and this large welding robot that you would see in the local industry. Our students get first-hand experience programming these robots and running complex programs you'd see in local manufacturing. Now what I've done to set up this demonstration is use a teach pendant, the little computer I'm holding, to develop a number of steps for the robot to follow. So it follows an X, Y, and Z axis, which means that it can move up and down and side to side and even rotate. It's really satisfying to see a program developed on a computer and then translated to this powerful yet delicate machine. You might notice the small weld wire that's barely touching the steel part. We're only simulating the welding part of this demonstration just for visibility purposes. The smoke and sparks make it real hard to see up close. Our students, they get to develop this from the ground up. It's up to them to code, troubleshoot, and perfect different scenarios you'd see in the advanced manufacturing industry. Some of the career pathways that you can get into, we've got things like robotics and automation, which would get you over at Matassa, AGC, or some of the places. We've got instrumentation process control, which would be chemical plants like Dow Corning, or water treatment plants, or maybe some of the distilleries. We also have the electronics, which goes into like Raytheon, or maybe even LG and EKU in Louisville as well. Those are some of the places you could go. Now some of the salaries you're starting usually around $52,000 a year. With a little bit of experience in a couple, 3 years, most guys are making upwards of 100 or over 100,000 a year. When I talk to my former graduates, the main thing that they say they love about their new job is the pay. They really like that high salary. They can provide for their family, they live comfortably, they can do the things they want to do now. They like the challenges, it's something different every day for them to go to work. They really enjoy it.
Wow, thanks, Marty. I'm not sure how familiar you are with robotics, but really I'm amazed every time I get to go down and spend some time down there with their students and seeing just how much they're learning about programming robots to do different tasks, different things like welding, to cleaning, to pick and place functions. Marty and our other instructors actually hit on one of the biggest draws for the advanced manufacturing field, which is pay. And while that's certainly not the only factor to consider, it is a pretty big one. And so let's talk a little bit about that. Our instructors were spouting out a few figures, a few salary figures, anywhere from $40,000 to $65,000, even to 6 figures for yearly salary. But I don't know if you know what that really means. That's got to be put into perspective for me. So let's talk about that. The median household income for Kentucky is about $48,000 a year. And we know that a lot of those households are actually 2-income households. So with a career in advanced manufacturing, you could be providing above the median income in Kentucky. So that really is something to think about. Now, advanced manufacturing isn't the only, tongue-tied, things happen. Now, advanced manufacturing isn't only just the programs that you've seen today. There we go. Which the programs you saw today were computerized manufacturing and machining, electrical technology, computer-aided drafting and design, and engineering and electronics technology, but it's also welding technology, which is one of the most highly paid of the skilled trades. and industrial maintenance technology, where you learn to install, repair, and maintain the machinery and systems that keep industry moving. All of these are two-year programs, two-year degree programs here at ECTC, with the options for diplomas or certificates that can be completed in a shorter amount of time. And if you think you want to get a bachelor's degree, you can absolutely follow some of those tracks within these programs to transfer into another college or university. And if you're thinking about something like engineering, make sure you check out options for knocking out your general education classes at half the cost. Our Associate of Science degree can be completed with electives in any of these programs to set you up for a bachelor's degree that will lead you into the manufacturing workplace. So if you're ready to find out more information about our programs, or just get more information about any of the options that we've talked about today, you can visit our website at elizabethtown.kctcs.edu, and there you'll find information on all of our programs, our scholarships, and our application process. And if you need any help along the way, please don't hesitate to reach out to us in recruitment at ECTCrecruitment@kctcs.edu. I've had such a blast getting to talk about these things with you all today. Thanks for hanging out with us. Let us know if you need anything.